Good evening. We're going to present the final project of numerical methods presented by Agustín Borrego, Germán González, Miguel Hernández, Iñaki Jauregui, and me, José Antonio Velarde. There will be 4 phases on the presentation: problem statement, development of process, trapezoidal method done manually, and corroborating the results. We were assigned problem number 7, which says to simulate the thermal characteristics of disc brakes DA Secrets and RW Hornbeck needed to approximate numerically the area average lining temperature of the brake pad from the following equation, where RE represents the radius at which the pad disc contact begins. R0 represents the outside radius of the pad disc contact. Angle P represents the angle subtended by the sector brake pad, and TR is the temperature of each point of the pad. Obtained numerically from analyzing the head equation. Suppose RE equal 0.308 feet, R0 equal 478 feet, angle P equal 0.705 radians, and the temperatures given in the following table have been calculated at the various points on the disc. Approximate T.
Development of the process. To solve the application problem, the trapezoidal rule will be used, which is the following. In numerical analysis, the trapezoidal rule is a technique for approximating a definite integral that works by approximating the region under the graph of the function. In order to approximate the value of t, its equation with integration should be solved taking into account all the tabulated data of the different temperatures registered across the different radii of the brake disc.
The points. The graph of the data points is the following.
Trapezoidal method steps. Number 1. Given integral to be evaluated. Number 2. Given tabulated data for the function values. Number 3. Compute the function values for the numerator. Number 4. Compute the function values for the denominator. Number 5. Integral to be numerator. Number 6. Integral of the denominator. Number 7. Compute the value of the t.
In the method by hand, the first step we take is given integral to be evaluated. As we can see, this is the integral and this is the angle that we have to consider. The second step to perform is giving tabular data for the function values. This is the table that gives us the problem with its corresponding values. The third step is compute the function values for the numerator. The function in the numerator is product of t, r, and theta of p. The fourth step is compute the function values for the denominator. The function in the denominator is product of r and theta of p. The yellow cells in the table are the demoliting values of the integrals both for the numerator and the denominator. The purple cells are the first and the last values of the results of the formulas of the numerator and the denominator, and the green ones are the green values obtained by the formulas without counting the first, not the last value evaluated. Now we use the formula of the trapezoidal rule both for the numerator and for the denominator. The blue cells indicate the results obtained in each one, being 49.717144 the value for the numerator and 0.047011 the value for the denominator. The final step of the process by hand is obtaining the approximate value of t. dividing the numerator by the denominator previously obtained. The final result is 155.3471 degrees Fahrenheit.
To you how we did our MATLAB code. First, we established the variables with the given data. Then, we compute our functions with values of the numerator by multiplying our matrix T with our matrix R and then by our value of theta. Then, we compute our functions for the values of the denominator. We're going to multiply our matrix R with our value theta. Then we're going to plot our given tabular data by using our function plot. First, we're going to put our matrix R, then our matrix T, and we're going to specify the color. Then we're going to plot the function behavior by using the same function plot, putting R and then T. Then we're going to integrate the function values from both the numerator and the denominator. With our values integrated, we're going to divide the numerator over the denominator to obtain the result. Finally, we're going to interpolate R with the result thrown to plot it afterwards.
We can see that the graph thrown by MATLAB software is the exact same than the one we did in Excel. The blue dots represent the tabulated data given by the problem, and the tiny little red star represents the result we got already fitted in the graph. We can corroborate that the result we got is correct because it's the exact same than the one we got by hand.
Conclusions, we can ensure that the temperature for disc breaks, taking into account the values obtained along the different radii of the disc path and an angular inclination of 0.7051 radians, is approximately 1055.3471 Fahrenheit degrees. In this slide, we show the referential sources consulted in order to carry out this project. And well, this is all. This is the final of our presentation, and we have to thank you for your attention.